So in the previous question, we were working out that w is which is equal to 2 plus 2 root 3 is equals in polar form. That's going to be 4 cos pi over 3 plus I sin pi over 3. And we're told, so if you want to go back and have a look at the previous question, you can do so. So we're told z4 is equal to w. So when we have z raised to a power of 4 is equal to w, we have to let this z4 equal w. But then when it's z to the power of 4 is equal to w, that means we have to find 4 solutions for z. So we're going to have to write it in general polar form because we want to get 4 solutions. So general polar form is we just add on a rotation. So say this, so pi radians is 180 degrees. So 180 degrees equal to pi radians. So pi radians, so 360 degrees will be equal to 2 pi. So we're going to add on a rotation of 2 pi each time. So it's going to be 4 cos pi over 3. So I'm going to write 2 pi n because n is the number of rotations, which we can change. 2 pi n, so that's plus I sin pi over 3 plus 2 pi n. So that's what w is equal to. So, but we're told that that's equal to z to the power of 4. So if you want, so z to the power of 4 is equal to w. So z is equal to w to the power of a quarter. So I'm going to have to write this all to the power of a quarter. So I'm going to get 4 cos pi over 3 plus 2 pi n plus I sin pi over 3 plus 2 pi n, and that's all to the power of a quarter. But we know from the Moivre's theorem that if we have a whole complex number in polar form, all raised to a power is going to be the modulus by the power and the angle multiplied by the power, and this angle multiplied by the power as well. So I'm going to write that out. So it's going to be 4 to the power of a quarter by cos, so that's going to be pi over 3 by a quarter plus 2 pi n by a quarter, and that's going to be plus I sin, that's going to be the same here, pi over 3 by a quarter plus 2 pi n by a quarter. So I'm just going to have to work that out for myself there. So I'm going to go on to my next line. So 4 to the power of a quarter is root 2, because root 2 by itself 4 times will give us 4. So that's going to be cos, so pi over 3 by a quarter, that's going to be pi over 12 plus, so that's going to be 2 over 4, which is going to be just half. So pi n over 2 plus, it's going to be the exact same in this one, plus pi n over 2. So that's a 2, sorry. And then, so when we're asked to solve, we have to go from rotations around the origin. So when we have to solve for this, we have to first let n equal 0. And because there's 4 solutions, we have n equals 0 is our first one, n equals 1 is our second one, n equals 2 is our third one, and n equals 3 is our fourth one. So the first thing we have to do is let n equal 0 and find a value. So that's just going to be cos pi over 12 plus I sin pi over 12. So I'm just going to plug that into my calculator and see what I get. So it's root 2 by, and just make sure your calculator is on radians so you're able to get the correct answer. So that's pi over 12, and so I'm just going to multiply root 2 by cos pi over 12, and then so for the first one it's going to be 1 plus root 3 over 2, and then I'm going to multiply root 2 by sin, so then it's going to be, for our next part, it's going to be plus I multiplied by minus 1 plus root 3 over 2. So that's our solution for n equals 0. And I'm going to go on to a new page for n equals 1. Just bear with me 1 second. So I'm just going to write out our general polar form. So it's going to be root 2 by cos pi over 12 plus n pi over 2 plus I sin pi over 12 plus n pi over 2. And now I'm already after getting the solution for n equals 0, so now I'm going to have to let n equals 1. So 2 cos pi over 12 plus a half pi over 2 plus I sin pi over 12 plus pi over 2. So now I'm going to work out an answer for this. So pi over 12 plus pi over 2 is going to give me an answer of 7 pi over 12. So I'll just work 7 pi over 12. So cos, so root 2 cos, and that's going to be 7 pi over 12. So that's going to be an answer of, so multiplying it by root 2, my real part is going to be 1 minus root 3 over 2. And then my imaginary part is going to be plus I, and it's going to be 1 plus root 3 over 2. And that's all multiplied by I. And then our next solution we have to get is n equals 2. Second rotation, so it's going to be cos pi over 12 plus, it's going to be 2 pi over 2, so that's just going to be pi plus I sin pi over 12 plus 2 pi over 2. So that's just going to be root 2 cos, so root 2 cos, and then it's going to be pi over 12 plus pi, and then I get an answer of minus 1 plus root 3 over 2, and then I have to get my answer for sin, now my imaginary part. So I get an answer of plus I 1 minus root 3 over 2. I is being multiplied by 1 minus, and for our final, so that's our n equals 2 solution, and then for our final solution I'm going to have to let n equals 3. And note there are only 4 solutions, the first being n equals 0. So root 2 by cos pi over 12 plus 3 pi over 2 plus I sin pi over 12 plus 3 pi over 2. So I'm going to work 3 pi over 2, sorry. So I'm going to work this out now. So I'm going to get root 2 cos pi over 12 plus 3 pi over 2, which is minus 1 plus root 3 over 2. And then for our imaginary part, it's going to be sin of the exact same quantity, delete and sin. So I'm just going to, pen is just after falling, so I'm just using a different color pen for this next part. It's going to be minus 1 plus root 3 over 2. And that is our third solution, and because it's a z to the power of 4, we only need to get 4 so that's our fourth solution. N equals 3 is our fourth solution, and because it's z to the power of a quarter, we only need to get the 4 solutions, so that's as much as we need to do. Thank you.